Assalamualaikum to Puan Najmiah. My name is Nur Ishira Izzati binti Karwa Anwar. My matrix number is B0821100056. Today I will explain about Lab 3 coefficient of static friction. The objective of this lab is to investigate the coefficient of static friction subjected to different angle. Number 2, to understand the relationship between the surface roughness and the coefficient of static friction. There are five laws in friction, which is friction opposes motion. Friction is independent of the area of the surfaces in contact. Friction depends on the nature of the surfaces. Friction is independent of relative velocity between the surfaces. Frictional force is proportional to the normal force exerted by the surface of the material in which a body rests. This is procedure. Part A, friction properties. Number 1, as shown in figure 2, click the following link. Number 2, the simulation was run and selected on friction. The box with mass of 50 kg was chosen. The friction was set to any non-zero value. The person was dragged toward the box by applying a force of 50 Newton on it. The observation were recorded. When box not in motion, which is static, the static friction force and its direction, applied force and sum of force were observed. The applied force was increased to 150 Newton. When box in motion, kinetic, the maximum value of the static friction applied force and sum of force were observed. Number 9, start over the value of friction was set to halfway. A second box was placed on the figure. On the first. In figure 3, carefully the values of the applied force were increased by using the buttons. When box in motion, the maximum value of the static friction, applied force and sum force were observed. The magnitude of applied force was found by move the box at constant speed. The applied force will increase to 500 Newton. While the box is still moving, the applied force was removed to 0 Newton. Immediately, the surface friction was reduced to none. The effects was observed on the box movement. Then the surface friction was increased to lots. The effect was observed on the box movement and the observation were recorded. Part B, coefficient of static friction. Set angle 0 degree, mass of M2 10 kg, COF between M2 and surface 0.25 wood. Click run and observation were recorded for the table B1. For the table B2, the angle was set into 30 degree, mass of M2 10 kg, COF between M2 and surface 0.25 wood. Click run and our observation were recorded. For the table B3, the angle was set for 0 degree, mass of M2 10 kg, COF between M2 and surface 1.0, dry concrete on rubber. Click run and our observation were recorded. For table B4, the angle was set in 30 degree, mass of M2 10 kg, COF between M2 and surface 1.0, dry concrete on rubber. Click run and record your observation our observation were recorded. Repeat step 4 and 5 and fill in table B4. This is the experiment data result. When box not in motion, static friction force and its direction 15 Newton to the left, applied force and its direction 15 Newton to the right, sum of force is 0 Newton. When box in motion, max friction force and its direction 94 Newton to the left, applied force and its direction 150 Newton to the right, and sum of force is equal to 56 Newton. When 100 kg box in motion, max friction force equals to 375 Newton. The magnitude of applied force necessary to move the box at constant speed equals to 375 Newton to the left. This is the table for table B1, part B, coefficient of static friction, table B1, table B2, table B3, and table B4. This is the question and discussion. Number 1, plot M2 versus M1 using data from part B. Calculate the COF for every cases. This is chart 1. This is the line graph for number 1. This is the line graph for number 2, chart 2. table B2. This is line graph for chart 3, table B3. And this is line graph for table B4. This is the calculation for the every cases. Number 2 is state what can you observe from the values of COF from the experiment. The larger the value of COF, the rough surface it will be. The table 1 and 2, the coefficient is less than 1 because it's used wood box, while table 3 and 4, the coefficient of frictions is bigger than 1. It is because the dry concrete is rough than the wood box. State the effects regarding on the type of materials to the values of COF. The friction generated depends upon the roughness and smoothness of the sliding object. The rougher the object, the more friction it will be to generate and its movement it will become restricted. The smoother the object, the more smoothly it can move. Number 4, state the main error that will affect the result from the experiment. The material of the plane having an inconsistent surface leading to an inconsistent average microsecond or the various angle. For the conclusion for this lab, in the conclusion, students learn how to investigate the coefficient of static friction from various angles. Students determine the coefficient of friction through experiments such as measuring the force required to overcome friction or measuring the angle at which an object will start to slide off an inclined plane. The student learned how to stimulate using the physic website and was able to obtain the result data through simulation. Besides that, students comprehend the relationship between surface roughness and static friction coefficient. The coefficient of the static friction was found to be affected by the type of material used and the angle at which it was applied. Thank you.